Hello together. This video explains you how to use the L5X export of our Ethernet IP API system in Logix. What you are seeing here is a Logix project with guard Logix, and at the moment I have not connected any Ethernet IP device. To do here now the configuration of our API system with the Ethernet IP node, you have three possibilities. The first possibility would be to use a generic EDS. The second possibility would be to use the Festo EDS. And the third possibility would be to use the L5X export. In the first two possibilities, you have to take care about the I/O size, the configuration assemblies, etc. And if you are using the third possibility, then in my opinion, it's very easy to get the project running with our Ethernet IP node, and you have some advantages which I want to show you right now. You see here, at the moment, I have no Ethernet IP connection. That's the reason why the LED here is flashing. And if I want to do now this L5X export, then I have to go to the web server of our API Ethernet IP node. You see here now my system in the web server, and here the tab Ethernet IP. If I click here on the tab Ethernet IP, then I have here the possibility to create such project. Click on the Rockwell project. I'm defining here in the first field the name, my first project. Then I have here the I/O assemblies, where I'm for the video choosing the fitting data type. Then here the configuration assemblies. If I want to use configuration assemblies, I have the advantage that I can do inside the PLC the startup parameterization for the whole API system. That's the reason why I say, okay, I want to have the complete system. And here the status assembly, if I'm using this, then I'm getting the option in the L5X project to use also diagnostic of our API system. If I want to have details to the different options, just click here on the information button and everything is explained. Here now I'm pressing this button, and then you see here the download button. And that was it. My project was created right here. Now I can go back to my Logix environment, and to make now this import, I'm opening a second instance. Here is now the second instance of my Logix environment, and here is open existing project. Now here is now the path for my project, and I can do here now my first project import. Just click on it. Then Logix is opening in the background the project as a second instance. This takes a little bit time. You see now it is popped up already, and the first thing what I have to decide is where do I want to save my project. In my case, I'm using just the desktop, and very important is here the revision. Depending on your main project, which revision you are using, I recommend to use the same. In my case, you see here it is 32, means here I'm using also 32, and start the import. Now the second instance is trying to open the project. This takes really around, mm, depending on your laptop performance, 1 minute, I would say. And in the meantime, I'm going here just offline, make this here a little bit smaller, and wait till Logix has opened the project. Okay, now Logix is starting to importing my project and is opening it in the second instance. And what do we get by this L5X export? The first thing what we are getting is here we have the generic Ethernet module, and if I'm opening this, you see here everything is defined already. We have using the right assembly instances, we have here the status, we have here the configuration with the right size, etc. It means I as user have not to take care how I have to fill out these sizes for the right communication. I'm getting everything automatically. To use now this Ethernet IP node inside my main project, I'm just making here a click and copy it directly here to the Ethernet. It was the first step. The second step is with the new API system, we have also user-defined data types inside the project. If you are using this data types in your main project, then you have some of the advantages which I'll explain later. For me, as user, very important, I mark everything and again, copy paste to user defined. Next thing is I'm going to the controller text. Here in the controller text, you see here that are the row data. That are the row data from the Ethernet IP node. And here we have also defined data, my first project inputs, my first project outputs, my first project status, which are belonging to the user-defined data types. I go here to edit text. In my main project, I'm going also to edit text, and I mark these three types which are here in the main project missing. So the last step is I'm going here now to the main routine. You see here we have used the CBS functionality to make a copy paste of the row data to this free text here. To do this in my main project, I also mark this, and I'm going here to the main routine and copy paste it directly inside my main project. That was it. That were the 4 steps to integrate the L5X project in my main project. I can now close the second instance, and I can do here directly the download to my PLC. Go to remote run, and the first thing what you are recognizing, everything is running without any error. We have now built up the Ethernet IP relation. We see here also on the real system that the NS light is not flashing anymore. It is green, means we have a communication via Ethernet IP and our guard Logix PLC. If we have now a closer look inside our parameter text, no, controller text, sorry, then we see here the advantages. The first thing what you will recognize is if you go here to the configuration text, that here inside the values are the startup parameters of your system. If you scroll here to the right, then you are finding also the description for the parameters. You can now change the startup parameters by modifying the values here. Therefore, I'm recommending to have a closer look in the API module manual, and with this information from the manual, you can define here other startup parameters, and after this change, the PLC will always send the new parameters during power off on of the API system to our node. And everything is done inside the PLC. This is the first advantage. The second advantage you see here, my project inputs and my project outputs. If you're using the generic EDS or the standard EDS, you are just getting the raw data. Here is the raw data. You see here we have the system with the raw data information here available, but we have some challenges because there is no description, and from the beginning we don't know really which value belongs to which module, how can I switch on the coils, etc. To do this, to build up the relation, to know the relation, you can of course go to the web server, and if you go to the web server, you see here the assembly view, and with the assembly view and a closer look on the assembly what you are using in your project, you see here also the offset and the bit length and the module information. Based on this information, you can find out very easily which modification has which influence. With the L5X export and this CBS instruction and the UDTs, this is not a must. You can also go here to my project inputs and my project outputs. That are the new tags which we have defined. If you have a closer look here on our new tags, then you see here on the right side the description. And you see here, if I have a closer look on the description, directly the information about the coils. Here the IO link master, here the 4D IDO. That means I can now make a modification very easily because I'm knowing exactly what I am doing here, which tags belong to which API module. If you go here, we know here this is the coils, then I can make here the modification. And then what I'm getting here in the real system, you see here, all my coils are now on of the VTUG Wolf terminal, and I have a really easy way of handling the data inside my project. That is the second advantage. And the last advantage is if I'm going here to my project status, then I'm knowing exactly the diagnostic information. You see here, we have at the moment no diagnostic active. If I'm going here to my system and creating an undervoltage error, then you see the LEDs are flashing because the power load is now disconnected. And if I'm going to my project, then I'm knowing exactly, okay, we have 5 active diagnoses, which is meaning that 5 modules have no power load anymore. And we have here the 4-byte message for undervoltage. This message belongs to the manual. If you go in the manual, you see exactly what this message is meaning. We can do this right now. And we are now here in the support portal. We're opening here the instructions. And if I'm going here to diagnostic and fault, then I see here, for example, here, switch off load supply 02, 01, 01, 06. Going back to the project, 02, 01, 01, 06. This is now the third advantage. We have the diagnostic in our tags, and to make it now very simple, this is the L5X export with 3 big advantages. You have the startup parameters inside your tags. You have a clear description, what is which output input meaning, and you are getting the diagnostics all in your project also inside the tags. And this is, in my opinion, very helpful. That's the reason why if you can do this L5X export and can use it, I strongly recommend it. And that was it. Thanks for your attention. Have a nice day.